Year 10 Trigonometry, Bearings and Trig Problems. We need to start off by recapping some of the things that you've learnt about bearings from Key Stage 3. You might remember that there are 3 golden rules of bearings. Bearings are measured from the north line, which is a vertical line drawn like so, and we label it with an N for north. Bearings are measured in a clockwise direction, so for instance like that or like that. And bearings are expressed as 3 figures. For example, the bearing of a boat from an island is 084 degrees. The key here is that we're looking at the boat from the island, which means we start from the north line of the island because we are going from the island. We turn clockwise until we hit the line that joins us to the boat. And that is a bearing of 084 degrees. Let's now find the bearing of the island from the boat. This means that we start from the north line of the boat and we rotate in a clockwise direction until we hit the line joining us up with the island. That's the bearing of the island from the boat. Now, to work out this angle, we're going to calculate the size of this angle first of all, which I'll call x. We know that x add 84 degrees must equal 180 degrees. We have what we sometimes call co-interior angles, which add up to 180 degrees. This means that x is equal to 180 take away 84, which equals 96 degrees. The bearing that we are looking for of the island from the boat is then this angle, which is 360 subtract x, or 96, which gives us an answer of 264 degrees. Now it's your turn. For each example, find the bearing of point B from A and then the bearing of point A from B. You can pause the video at this point and the answers will come up shortly. So we're going to run through the answers. For part 1, the answers of the bearing of B from A will be in red, and for part 2, the bearing of A from B will be in blue. So for the first question, the bearing of B from A is 065 degrees. The bearing of A from B, which means we start from B, is this angle over here. Again, as we did last time, we can work out the size of this angle, which is 115 degrees. And we can then work out the bearing by doing 360, take away 115, which works out to be 245 degrees. For the second question, the bearing of B from A, again, we start from A. The answer is 150 degrees. And then for part 2, the bearing of A from B is this angle here. We know that this angle here has got to be 30 degrees. So the answer that we are looking for is 360 subtract 30, which is 330 degrees. And the last question, the bearing of A from B and the bearing of B from A. If we start with the bearing of B from A, that means we're starting from A's north line, we're going round like this, so the answer is 220 degrees for part 1. For part 2, the bearing of A from B, that means we start from the north line of B and we go around clockwise, it's this angle here. So again, we can calculate this angle in here, which this time is equal to 360 take away 220, which is equal to 140 degrees. The angle that we want, this one, is then equal to 180 take away 140 degrees, using the fact that these two angles are co-interior because they sit in between two parallel lines which are joined by this line here. So this angle in here is equal to 40 degrees, but of course bearings have to be given in three figures, so the answer is 0, 4, 0 degrees for the bearing of A from B. We're now going to have a look at some problems involving bearings and trigonometry. In each example, we need to sketch a diagram, look for the right angle triangle, make sure it's labelled, and then use trigonometry appropriately. Question 1. A bird travels 8 kilometres on a bearing of 056. How far east is it from its starting point? So my starting point is going to be here, and I'm going to draw in a north line, like so, and a bearing of 056. Well, I know that would be a bearing of 090, 90 degrees. I want a bit less than that, 056, so it's possibly going to be something like this. That's the journey of the bird, and it travels 8 kilometres. It ends up at this point over here. Let's fill in the angle, 056 for the bearing. Now, let's think about compass directions. We've got north, east, south, and west. So how far east is it from its starting point? Well, that means if we draw in that vertical so it's a bit longer and then join across there, this is the measurement that we are trying to calculate. That's how far east the bird is at the end of its journey compared to the start of its journey. So we have a right angle triangle. Let's label the sides according to this angle over here. So we have the opposite, we have the hypotenuse, and we have the adjacent. We have been given information about the hypotenuse and we have to work out the opposite. So that means that we're going to need to use sine for this. Again, some of you may want to use your SOHCAHTOA triangles. We're trying to find out the opposite, which is x. And of course, this is equal to sine 56 multiplied by the hypotenuse, which is equal to 8. And you can work that out on your calculator. This is equal to 6.6323, etc. And we can round that to 6.63 kilometres to 3 significant figures. Question 2. A ship travels for 2.5 kilometres on a bearing of 120 degrees. How far south is it from its starting point? So again, let's decide on the starting point of the ship. There is north. Now 120 degrees, we know that a quarter turn is 90 degrees, a half turn is 180 degrees, so a bearing of 120 might perhaps look like that. So the end of the boat's journey is around here. We need to work out how far south it is from its starting point. So if we draw in a right angle triangle like that, this is the measurement that we are looking for. And here is our right angle. Now we're going to have to do a little bit more work. We need to know the size of one of the angles in this right angle triangle. So we're going to work out the size of this angle here, which of course is going to be 120 take away the 90 for the right angle that is here, which means that this angle is 30 degrees. Let's label the three sides of the right angle triangle. The hypotenuse, x is the opposite, which is opposite this angle of 30 degrees, and this is the adjacent left over. Now, we also know that the ship travelled for 2.5 kilometres, which means the hypotenuse is 2.5 kilometres, which means that we know what the hypotenuse is and we need to work out what the opposite is. So we have another situation where we're using so or sine. So from here, we know that we want to work out what the opposite is. So that is equal to sine of 30 multiplied by h, which is 2.5. And if we work that out, that comes to an answer of 1.25 kilometres. So x is equal to 1.25 kilometres. The ship is 1.25 kilometres south from its starting point. Example 3. Boat A is 10 kilometres north of a port. So if this is my port, boat A must be over here in a northerly direction, 10 kilometres north. Boat B is 5 kilometres east of the same port. None of this is drawn to scale. So there's boat B, and it's 5 kilometres away from the port in an easterly direction. Boat A sails in a straight line towards boat B. Work out the bearing on which boat A sails to reach boat B. So, if we draw in the north line for A, the bearing is this angle here, which means that we need to find the size of this angle and subtract that from 180 degrees to get the bearing. Here's the right angle. Let's label some sides. If we use x, the angle x as our reference, this is the hypotenuse, of course, this is the opposite, and this is the adjacent, which means that we are focused on the opposite and the adjacent, which means that we are using tan, or the TOA triangle. We know what O is, we know what A is, so it's T that we are trying to find out. So we know that tan of the angle must equal the opposite divided by the adjacent. So tan x must equal 5 divided by 10. So x equals tan to the minus 1 of 5 divided by 10, which comes to a value of 26.565 degrees, or 26.6 degrees to 1 decimal place. Now we're going to work out the bearing. So actually this rounded answer isn't really relevant to us. So I'm going to get rid of it because we don't need it. The bearing is going to equal 180, subtract our value of x, which is 26.565. Remember, never round in the middle of a calculation. This is equal to 153.434 ... degrees, but because bearings need to be three figures, we're going to round it to 153 degrees to the nearest whole degree. Example number 4. The diagram shows 2 points A and B. Work out the bearing of B from A. So, if we draw in a north line at A, and we join A and B together, the bearing of B from A means we start from A and we go around like that. Now, to work this out, we're going to need to find the size of this angle here, x, and add it on to the 90 degrees up here. So looking at x, we can label the hypotenuse, we can label the opposite, and we can label the adjacent. We know the adjacent, we know the opposite. We're trying to find angle x, so this is another question in which we need to use the TOA triangle or tan. So tan of x is equal to the opposite divided by the adjacent. So tan x is equal to 55 divided by 40, and x is equal to tan to the minus 1, 55 over 40, which works out to be 53.97, etc. We won't round this value. So the bearing of B from A is equal to 90 plus the value of x, which comes to an answer of 143.97, etc. And again, we want to round it to the nearest whole degree, as bearings are given as 3 figures.